Tossing a coin, rolling a dice, or shuffling playing cards are all areas where we can practice our problem-solving skills. On many occasions, you may need to know what the chances or probability is of something happening, such as cracking into somebody's computer account. With a few simple techniques, it is possible to break down a complex problem into simpler elements that makes the whole process easier to understand. The first thing is to recognize the difference between simple and complex problems. Let's call a simple problem one where only a single thing happens, like tossing a coin once, or throwing a dice once, or drawing a single card from a pack. Let's look at some examples. The secret is to note the outcomes you want and all the possible outcomes. Let's take the toss of a coin first. What's the chance of tossing a head? Well, there is only one head on each coin, unless somebody's slipped you a dud, always worth checking. So the outcome you want, the head, is only available once, and the total of all possible outcomes is 2. Write this down as 1 over 2. It's the same reasoning for throwing a tail. There is only one tail on a coin, so the outcome you want is 1, with the total number of options, heads or tails, 2. So again, it's 1 out of 2. Similarly with the dice. What's the chance of throwing a 5? Well, the outcome we want is 5. There is only one 5 on a normal dice, although it's better to check that nobody's bucking you around. And the total number of possible outcomes is 6, as a dice has 6 faces. So the chances of throwing a 5 is 1 out of 6, just like all the other numbers. What's the chance of throwing an even number? Well, the outcomes we want are an even number, which are 2, 4 and 6. So 3 outcomes. 3 outcomes on a dice with 6 faces, that's 3 out of 6, or a half. What's the chance of drawing a king from a pack of cards? Well, there are 4 kings in a standard pack of cards. Always better to check in case someone has tried to scam you. So there are 4 possible wanted outcomes from a total of 52, a full pack of cards. So 4 out of 52, or 1 in 12. What's the chance of drawing a red card? Well, we want a red card, so there are 26 red cards in a normal pack, so the chances are 26 out of 52. So, writing down the number of good outcomes that we want for us over the total number of outcomes always provides the answer in these simple cases. The next level of difficulty is if you need to know the chance of 2 unrelated things happening. Take the coin example. The important thing here is to know whether things are related. If on the first toss of a coin I get a head, does it affect what happens the next time I toss the same coin? Well, of course it doesn't. In the same way as throwing any number on a dice does not affect the next number that was thrown. They are all unrelated events. When things are unrelated like this, you can simply multiply the chances of the 2 single events together to arrive at your answer like this. What is the chance of throwing 2 6s in a row? Well, we say above that the value we want is 6 on the first throw. The chances of this are 1 out of 6 possible outcomes. So throwing 1 6 is 1 over 6. And the second throw is also 1 over 6. Multiply the 2 together, and the chance of getting 2 6s in a row is 1 over 6 times 1 over 6, which is 1 over 36. Remember to multiply, not add. The chance of throwing 3 6s is 1 over 6 times 1 over 6 times 1 over 6, i.e. 1 in 216. Throwing 6 6s in a row is 1 over 6 by 1 over 6
times 1 over 6 times 1 over 6 times 1 over 6 times 1 over 6.
Let's now take 2 examples from class. First, the bicycle lock. What's the chance of selecting the right combination? Well, the first question to ask is this a simple question or a complex one? And if it's a complex problem, can it be broken down into several simpler problems? Well, the bike lock has 4 numbers on it. Each reel has 10 digits on it. All have to be correct to open the lock. Unless someone sold you a dud lock, it's always worth checking. So, it's a complex problem, 4 reels, but can be broken down into 4 simple problems. Write down the wanted outcome over the possible outcomes. There is only one number that should be correct on the first reel out of a total of 10 outcomes. Don't forget, every reel has every digit from 0 to 9 on it. So the wanted outcome is 1 out of a total possible of 10. It's the same for the next reel, and the next and the next. So the chances of selecting the correct number is 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10 equals 1 over 10,000. Now some people said this was impossible, but it's not. Given enough time, you could work through every single combination until the lock opened. Like all codes, it is not safe and only takes time to break. When a cracker is trying to access your machine, he will be using a computer that will be able to test hundreds, if not thousands of times a second. So beware, it only takes time. We looked at PIN numbers. What do we know? PIN numbers don't have any letters in, they just have numbers, and only 4 of them. Break the complex number of 4 numbers down to 1 at a time. The first number we want is just 1 out of the 10 possible on the ATM machine. The second number is also 1 out of 10, and so for the third and fourth. So the chances of getting a correct number first time is 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10, 1 in 10,000. But the ATM machine allows us to make mistakes. It allows 3 chances to get the number right before it chews up the card. So our chances go up from 1 in 10,000 to 3 in 10,000. Is this secure? There is only one slightly more complex problem still. That is when the outcomes are related. In the National Lottery, all you have to do is to pick 6 correct numbers from 49. Now we see this is a complex problem, as there are 6 events we want to happen from 49. So, to draw any one of the 6 numbers out of the 49, the chance is 6 over 49. Now, as this is one of the correct balls, what is the chance of drawing a second correct ball? Be careful here. It's not 5 in 49, because we've already removed 1 ball. The chances we want is 5, but out of 48 remaining balls. Assume this works, then our next ball is 4 out of 47, and so on. So the chance of winning the lottery are 6 out of 49 times 5 over 48 times 4 over 47 times 3 over 46 times 2 over 45 times 1 over 44, which works out to be 1 in almost 14 million. 1 in 14 million. Good luck. So how do we apply what we've learned to passwords? Well, what is a password? It's a combination of 26 uppercase and 26 lowercase letters, 10 numbers and say 10 punctuation marks. So in total, there are about 72 characters to choose from. If we want to crack somebody's password, what are the chances? Well, if they're chosen badly, say a 5-character name, all in lowercase, then the chances of guessing the first character is 1 in 26. And the chances are the same for the second, third, fourth and fifth character. Compare this with what is called a strong password using all 72 characters. The chances are multiplied by 1 over 72 for every character in the password. Obviously, the longer the password, the more difficult it is to crack. Now, these may seem large numbers, but crackers use computers that will try thousands of passwords a minute. Their systems are likely to be automated and could use compromised machines to launch further attacks on other machines. This is how a great deal of spam is transmitted and how botnets are formed. Methods of attack include things like dictionary attacks, where a dictionary of English words is used rather than directly trying every combination. That's known as a brute force attack. In truth, systems should be programmed to stop after a few incorrect tries, like the ATM machine. This is set up by your system's administrator. And crackers are looking for an easy target. They'll decide when it's more fruitful to move on to past as new. Don't make it easy for them. Select your passwords wisely.